welcome to this episode. I'm Sung, I'm the Principal and Director of Sky Academy, and in this episode what I want to do is look at something that you're probably familiar with, scientific notation. Another word for scientific notation is standard notation. So you may or may not have seen this, but let me just quickly go through what scientific notation is. Scientific notation or standard notation is basically a way of expressing numbers that are unusually large or unusually small, where expressing them in the conventional way would be impractical. All right? So for example, if you were to work out the distance between the Earth and Pluto, in centimeters for example, then basically it's going to be a large number. It's going to be pretty big, and oftentimes it's going to have so many zeros on the end of it that to write all those zeros would just not be practical. So if you had, for example, you move beyond millions and billions and you move towards one with 50 zeros on the end of it, right? Then you're not going to write 50 zeros each time, right? So what you then use is a method called scientific notation, and it makes things a lot easier, right? So you express things in scientific notation, which will look something like this. It'll be one number times 10 to the power of another number, and these are the rules that you need to know when expressing a number in scientific notation. This number here, the first number, has to be a decimal between 1 and 10. It can't be 10, it's got to be less than 10, right? Can be 1, right? But it can't be 10, right? As soon as it becomes 10, you just make it 1, right? So it's got to be between 1 and 10. The whole number, by the way, is also a decimal, right? It might not have the decimal point, but it would be 0.0, right? So it's got to be a decimal between 1 and 10, and this number has to be an integer, positive if large, if it's a large number, negative integer if it's a small number. So if it's got a large magnitude, like the distance between here and the furthest most planet, then it's obviously going to be a positive power of 10. If it's really small, like the width of an atom, for example, it's going to be a really small number, and therefore the power will be negative. Alright, now the type of question that you might be asked on scientific notation are how to convert scientific notation, or a number expressed as scientific notation, to a conventional number. How do you convert a scientific notation to a conventional number? How do you convert a conventional number to a scientific notation? And the last type of question that you might be asked is how to operate, so plus, minus, times or divide with scientific notation numbers involved. Okay? Now, you're probably not going to encounter a question that it will specifically be a scientific notation, but what you will find is oftentimes you'll do other questions which will result in a number being really large, which then the examiner will say, express your answer in scientific notation. Okay, so they're the type of questions that you'll be likely to be asked. I'll give you an example of a scientific notation, a number in scientific notation. You might have, for example, 6.125 times 10 to the power of 18. Yep, that might be meters, and that might be, for example, the distance between here and the star or whatever. I don't know. But that's an example of a number in scientific notation. Or you might get 2.015 times 10 to the minus 20, right? Which might also be another number, a really small number this time, expressed in scientific notation. I'm gonna rub this off the board now, and I'm going to come back with a couple of questions that we might want to answer together. One that fits into each of these three different categories, and we'll look at how we solve them, and then that will be you know, a good grounding in scientific notation. So I'm going to press pause, and I'll see you on the other end of this this video. All right, thank you. Welcome back. And I've got 4 questions up on the board, and these 4 questions ask us to express these numbers in scientific notation, which is exactly what we're going to be doing. So for example, 12 million will be 12 with 1, 2, 3, 4, 5, 6 zeros. To express that in scientific notation, first of all, what we've got to do is is to see what number between 1 and 10 we need to multiply as a power of 10, by a power of 10. So 1.2, so the decimal point would go between the 1 and the 2, so it's 1.2 times 10 to the power of, so if we put the point between 1 and 2, how many decimal places have we shifted it from here? So let's count. 1, 2, 3, 4, 5, 6, 7. We've shifted it 7 places. So it's 1.2 times 10 to the power of 7. Okay? And we know that it's positive 7 because 12 million is a really big number. So 1.2 is your standard number. And we've got to make it bigger by a factor of 10 to the power of 7. Okay, good. Let's do this one. This one is a number that's almost in scientific notation. The only problem is, see, we've got 10 to the power of a number, which is fine, but what we find is 8.62 is not quite a number between 1 and 10, is it? So we've got to write that as a number between 1 and 10, and it's 8.62, which means that we've moved the decimal places 2 spaces. We need to move the decimal point 2 spaces to the right, which means this number would go up by 2 numbers. So it's 8.62 times 10 to the power of 4 plus the 2 spaces that we add, 6. Okay, so it's 8.62 to the power of 6. This number here, this time we're moving the decimal point 1, 2, 3, and we need to put the decimal point there because the number that's between 1 and 10, the first number, will be 5 point something. 5.002 times 10 to the, we're going 3 places to the left this time, so it's minus 3. Okay? And a good way of remembering this, if the number's a big number, we know that the factor of 10 will be positive, whereas if the number is a decimal or a really small number, the factor of 10 will be negative. Okay, in this case it's negative, right? Now, this question here, all right, is going to be a really small number. See how it's 0.000? So it's going to be a really small number. So it's going to be 10 to the power of a negative number. And how many places we moved the decimal place will depend on where we put the decimal place to work out the number, the first number. Now the first number will be between 2 and this 2 and this 2. So it's 2.2. And how do we work out this number here? Well, basically you start from the left and go to your first non-zero number. And the decimal point will belong after that. Okay? So it's 2.2 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. So it's 2.2 times 10 to the power of minus 7. Okay? We're going to do the next one, which is converting scientific notation to conventional notation. Okay? Alright, so welcome back. This time what we're going to be doing is looking at how to express scientific notation in conventional form. So we're going to be looking at this particular set of skills. Right? So for example, 6.2 times 10 to the power of minus 5 will be, so you write 6.2, and then what you do is you count backwards 5 spots. 1, 2, 3, 4, 5. So your decimal point will go there, and then you fill the rest of the blanks with zeros. right? So you should be going back 1, 2, 3, 4, 5 from 6. And you know that you're going this way instead of this way because the number is getting smaller. There'll be more zeros in front of the 6 than after the 6, right? Yep. So that's an example of how to do that one. 7.25 times 10 to the power of 7 would be, and then you write 7 to 5, and you start at the point between the 7 and 2, and then you count back 7 units, or 7 places. 1, 2, 3, 4, 5, 6, 7. So the decimal point will go there, and then you fill the blanks with zeros. Yep. So the answer will be 72,500,000. Does that make sense? Let's do this one. So here we're going negative 10. So there's going to be more zeros in front than behind. So you got 8.93 and you're moving this point 10 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright? So it's 0 point and then zeros out the front. See how it's starting to get really impractical to write? See how you got more zeros than you know what to do with. Alright? So it's actually more meaningful to see a number written in scientific notation like this than it is to see all these zeros and not know what to do with them. Okay? So that's that one. Alright? And just to labour the point, I'll just do one more, which is 6.37 times 10 to the power of 15. Alright? Which is, I'll start on this side because we're going to add zeros to the right because 15 is a positive number. So it's 6.37 and we're going 15 units to the right, 15 places to the right, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we put zeros in between, and that is an astronomically big number. Yep. So that is how you do. That's how you do questions that involve converting from scientific notation through to conventional form. So we've done this one now, and then all we have to do is to operate with scientific notation. And for operating with scientific notation, what you've got to do is basically use your calculator. Hi, welcome back. Now the next type of question that we want to be doing with scientific notation is being able to do operations with scientific notation. Okay. Now in terms of doing operations with scientific notation, I've got 3 questions up on the board, and to do them it's really simple. You basically just operate on your calculator. Okay. Just punch the numbers into your calculator and your calculator will do the job for you. However, I do want to introduce you to a special button on the calculator which will make the sums a whole lot easier. And if I bring my calculator right up to the camera, the button that I want to show you is this button here. Do you notice it? Alright, so it says times 10 to the power of whatever it is. Okay, now that is the button that I want to introduce you to. So the way that you enter the numbers in your calculator is, first of all, with the first question, write 3.2 times, or you don't need times, 3.2, and then you just press that button, times 10 to the power of, and then after that you type in the number 6, and that should give you the number 3.2 times 10 to the power of 6. And you just multiply, and then the next number is 4 times 10 to the power of minus 2. And for the minus 2, you need to remember to use this button there. Okay, that's your negative button, that's your minus button. Okay, that's your minus button, that's your negative button, and they're different. Okay, and you press equals, and it will give you a number, and that number you need to convert to scientific notation. And so I'm going to work out the other 2 answers, and then we can basically compare. Now, I just want to stop here for a second. These are the answers that you should have gotten. But I want to stop here for a second because when you put your numbers into your trusty calculator, see how you've got that division sign there? You've got to make sure that you put brackets around the 7 and brackets around the times 10 to the power of 2. If you don't, then you're going to divide by 7 and then times by 10 to the power of 2 rather than dividing the whole thing by that number. Okay? So it's just very important that you watch out for that. And the same thing with the plus. When you're adding this number, you've got to make sure that that number in scientific notations is in brackets. Okay. Well, that should be enough for you to be able to do scientific notation and to be able to do all the different types of questions involved with it. All right. But I'll leave it there. Thank you very much for watching.